We are going to talk about focusing on our word problems, no problem. And today our focus is going to be on multi-step problems. So as we get started here today, let me go ahead and click through. I'll go ahead and give you my email address, and I'm also on Twitter and only tweet about math things. So maybe we want to connect in that way. A few of you have already emailed me this week, which is great. Some people asked for the word problem mats, which I actually included in the handouts for today. And another person had some questions about a specific schema. I have put this entire presentation and all of the handouts on my website. So if you do go to sarahpowellphd.com and click on presentations, let me get this up here real quick. Then you can download this presentation and the handouts, as well as the presentation from Wednesday and Monday and the handouts from Wednesday and Monday. So those will be up there for a few weeks, and please do take them for your own information, and do feel free to share those with others as well. And then we are going to do a review and then head into our multi-step word problems. So we're going to start here. We are going to pick up with our ratios or proportions word problems. That's where we left off last time. But before we do that, I just want to do a quick review of everything we've talked about this week. So when we think about teaching problem solving, it's really important for your students to have an attack strategy, and then for you to focus on the word problem schemas. That attack strategy is important because it really helps students have a starting point and an ending point for problem solving. So a lot of us talked about using UPS check. I know a lot of you talked about using R cubes or other attack strategies. I always say that I don't really care which attack strategy you use, just as long as you have one. And you should be using it. So every time you're doing modeling or think alouds with word problem solving, you should be using that attack strategy, but then also encouraging your students to do it. So we'll ask our students, what do you do every time you see a mix of numbers and words? And we're like, we attack it, and we attack it with either we have a run attack strategy or a UPS check attack strategy. So either of those will work from the students there. And so making sure that they're using the attack strategy as they work on their own or with a partner or in small groups. So a lot of classrooms will have the attack strategies printed on bookmarks, printed on posters around the classroom, maybe even have a worksheet and it's just printed at the top of that, but really emphasizing the importance of that attack strategy. And then we would combine that. Oh, and I wanted to say our Google Jamboard is up there today. And remember, we have a page where everyone has shared their attack strategies. So if you go to the Jamboard, and I'll show you what this looks like real quick. I'll scoot over here. Oh, there we go. If you go to the Jamboard here on the first page, you can see all of our attack strategies. And then if you have some other, if you want to say like, hey, what are some example total problems or difference problems or change problems or equal groups and comparison or ratios and proportions problems, all of that information is there for you to borrow and use in your own teaching. So I like the Jamboard for just a good generation of ideas. And so then we combine that attack strategy with a focus on the word problem schemas. Now the schemas are really important because they help students see that every word problem isn't a totally different new experience. And in fact, there's a lot of commonality in word problem solving, and that commonality is what we call these schemas. So the 6 schemas that we regularly see in the elementary, middle school, and high school grades are total difference and change, and then equal groups comparison, and then ratios and proportions. And we've talked about these in isolation because many times we see them in isolation, like this is just a difference problem, or this is just a comparison problem. But today we're going to talk about combining these schemas, because often when it comes to multi-step problem solving, we're going to see problems that involve a combination of 2 schemas or and sometimes 3. So last time we talked about change problems, and you all provided some really nice change stories. So here we have a start amount that increases or decreases to a new amount. And then last time we also talked about equal group stories. So those are stories where we have groups with an equal number in each group. And I saw some really good equal group stories on the Jamboard. Here are just several. We also talked about comparison stories where we have a set that's compared a number of times. And there were really great comparison stories as well. And then we focused on stories related to ratios or proportions. So here we're starting to think about, well, what are the relationships among these quantities? And here are some examples of some of the different types of ratios or proportions problems that we can set up and solve. And often we'll use graphic organizers. We can also use equations to help solve these problems. And when we think about ratios or proportions problems, we want to have a question that cues students into, well, is this a problem where I'm going to think about a ratio or proportion? So we ask the question, well, are there relationships among quantities? If this is to that, then this is to that. So we can add that to our list of questions that we can ask students to help them really focus in on the schema. So on Wednesday, we solved problem E, but I wanted to take a little bit of time to solve problem F today. This is this problem about an airplane's altitude. So we'll work on this one as a group, and then I'm going to ask you to work on problem G on your own, and then we'll discuss problem H because that's going to help segue into multi-step problem solving. So I'm going to get my problem F booted up here. All right, let's see where we are. Great, looks pretty good. And we'll go ahead and solve this problem together. All right, so I see a mix of numbers and words. So that tells me that that is a word problem. So I'm going to go ahead and bring out my attack strategy immediately. That's going to help me remember to attack this word problem. So we have to understand this problem by reading it. An airplane's altitude changed negative 378 feet over 7 minutes. What was the mean change of altitude in feet per minute? So here I have to figure out the change of the altitude in feet per minute. So I'm going to underline those things because I want to focus on the number of feet per minute. And now I have an understanding of this problem, at least enough to help me go forth. Now I'm going to make a plan. So I could ask myself some of the multiplicative questions here. Is this a story where we have groups with an equal number in each group? Is this a story where we have a set compared a number of times? Or is this a story where if this is to that, then this is to that? Let's see, I'm thinking about feet to minutes and feet to minutes. So I'm going to solve this as a proportions problem. So I'm going to draw my graphic organizer in here. And I've got my plan to solve this as a proportions problem. Now we'll go ahead and put in the information. So I'll go back, and every time I see a number, I'm going to stop and ask myself, do I need that information from that number? So an airplane's altitude changed negative 378 feet over 7 minutes. So negative 378 is a number, and I'm going to compare that to minutes. So I need I should have written my box a little bit bigger there. So negative 378 feet in 7 minutes. So I'm going to check those off so I don't get distracted by them again. And then what was the mean change of feet per minute? So in 1 minute. So if we change negative 378 feet in 7 minutes, how many feet did we change in 1 minute? So I'll get my graphic organizer filled in that way. I'm going to just translate this to equation down here so that it's easy for me to see. I might use X to fill in for the question mark. So I'm going to say 7x is the same as negative 378. If I divide by 7 on both sides, I'll solve that x equals, I think I remember, negative 54. And if I think that that's feet per minute, remember I already underlined that. My label is getting a little bit off my workspace, but that's okay. So that would be the mean change per minute. So we solved the problem, and then I want to go back and check my work. So I could place in the negative 54 and do the math to check that negative 378 is to 7 as negative 54 is to 1. And we've always checked our work to make sure that it makes sense. So that was an example of using the proportions graphic organizer there. I'd like you to take, we'll just do about, let's see, I'm looking at my clock. Oh, I got tons of time today. Just about 2 minutes to look at this problem G. And then if you finish problem G, go ahead and start to look at problem H. So this is going to be our segue into multi-step problem solving with problem H. So just take 2 minutes there to look at that, and then we'll continue on with our work. All right, if anyone had an opportunity to solve problem G, what answer did you come up with when we had to figure out the amount of money in dollars that Sarah saved from the sale? Yeah, Jessica and Dana, good Friday morning math there. So $7.50. So with several of these problems, there's different ways that you can approach this. I would think about this as, 25 of 100, 25% of 100 is to X as to 30. So then solving in that way. But there are other ways that you could solve this. I know some people might think about this in using a different schema. And there are some times where two schemas can be applied to the same problem. That's not the case all of the time. But when students might say like, well, I think I could solve this using the equal group schema, I'd say, well, tell me about that and how could you use that? And if it's a strong rationale and it makes sense mathematically, then I encourage the students to use that schema. I mean, it shows you they've got strong schema knowledge. We will see this with the additive problems. Sometimes there are change increase problems that students will, excuse me, that students will think about as a total problem. And so I always say, talk me through how would you interpret this? What are your parts and what's your total? And again, if it's mathematically sound, then I'll say, yeah, that sounds like a really good idea. So DJ, you've got it. Looks like we've got a good idea about how to solve those problems. Now, we're not going to solve problem H because I have some other multi-step problems that I want us to solve. But you can see here we've now got these two aquariums. And so first we have to focus on one of the aquariums for the small fish, and then we have to figure out for the larger fish. And so here we're comparing, 5 is to 10 as what is to 200 to figure out the number of small fish that would be in that aquarium. And so this is going to be how students are often seeing a lot of these schemas is through these multi-step problems. So I'm going to leave problem H. If you solved it or if you're working on solving it, that's awesome. But I want to kind of move us along so then we can really get into some detail about this multi-step problem solving. Now, before I do that, I think it's a good time to pause and be reflective. I'm just going to skip that, about, what are these multiplicative schemas that we've talked about Wednesday and today? So I'm going to show 3 word problems and just give about 10 or 15 seconds to read the problem. And then if you have a guess as to whether it's an equal group story, a comparison story, or a ratios or proportion story, I'd like you to type that in the chat box there. So here's a story about Mr. Kowalski and his granola bars. So do you think this is an equal group story, a comparison story, or a ratios or proportion story? All right. So yeah, we see some equal groups. You're exactly right. So we've got 35 boxes of granola bars with 24 in each box. So we have groups times the number in each group equals the product. What about this story about a cell phone company making cell phone cases? Yeah, so Dana is thinking about ratios or proportions, and I would agree. I would use that here. So I would think about that as 625 is to 1 as what is to 31. So I like using that schema for this problem. And then here, Danielle's full-grown dog weighs 10 times as much as her puppy. The puppy weighs 9 pounds. What's the number of pounds that the full-grown dog weighs? So what type of story would we consider that? Yeah, Terry, yep, comparison story. So, yep, Dana, good job. All right, we've got a good understanding of those schemas. So now let's think about these word problem schemas. And before we start our multi-step problem solving, I want you to have a discussion with other teachers or other people that are here here today about these 6 word problem schemas. So I included some of the mats that we give our students to help them with their problem solving process. So this is the mat for total difference and change problems. Often we will laminate this so that students can fill in that graphic organizer and use it time and time again. And then you also see that we have the total equation, the difference equation, and the change equations, so that if they want to use the equations to solve these word problems, they're able to do that as well. And then on the next page in your handouts packet, we have the equal groups, the comparison, and the ratios or proportions schemas. So these are some of the graphic organizers that we'll use and some of the equations that we'll use with students to help them set up and solve these problems. So I've included those there. If you want to print them out, they're yours to use. If you want a separate PDF of them, just email me and I'm happy to share that with you as well. But keeping in mind these 6 schemas, I'd like us to do a little bit of a breakout for 5 minutes to think about these schemas in isolation before we start to combine these schemas. So we're going to break out here, and I'd like you to discuss the following. So which schemas are you going to teach your students? You know, which do you think that they already know pretty well, and which are new, which are novel? And you may have some students that aren't going to see or use all 6 schemas. So which ones are you going to focus on? And then thinking about those focus ones, how are you going to teach these? So I've talked a lot about the schemas, but maybe not as much about explicitly teaching them. So are you going to model? Are you going to practice? Are you going to do small group work, whole class group work? Like, what are some of the ideas that you have? I'd like you to share those with your fellow teachers. And then how are you going to take that attack strategy that we've been talking about and then put that in with the schemas? So what are some of the ideas that you have around that? So which schemas are you going to focus on? How are you going to teach those? And then how are you going to bring in that attack strategy? We're going to now break out for 5 minutes. We'll be in about groups of 6 or so. And then at the end of that 5 minutes, you'll be encouraged to come back to the main group, and then we'll launch into our multi-step problem solving. All right, so our group had a really nice discussion. People were talking about focus on some specific schemas, especially at their grade level, using the graphic organizers, using the attack strategy. So I think a lot of you are seeing how we combine all of those things. Now for multi-step problem solving, it's not going to be terribly different, all right? So we're going to continue to use that attack strategy and continue to focus on, well, what's going on in this story? You know, what's the action? What's the structure? That's the schema. And then we're going to continue to focus on that. Now, we're doing a little bit of work here in Texas about multi-step problem solving. And so we've actually taken our UPS check, and we call it now UPS check squared, because we've really have 2 U's, we have 2 P's, we have 2 S's and 2 checks. And so I share this with you if you want to use this, but we understand the problem by reading it, and then we underline the label or labels. So like really helping the students focus on, well, what are the multiple parts of this problem? Because now sometimes it's not just one thing I'm going to underline, but it might be 2 or 3 things we have to underline. We're trying to think about like marking the important numbers. So we're doing a thing with parentheses, and then putting the numbers in order, like what am I going to do first or second? And then we focus on the schemas, and then we solve it, and then we check our number answer and our label answer, because sometimes I was first focused on the pieces of pizza, but now I need to focus on the numbers of boxes of pizza. And so what would be an appropriate label answer? So you may want to, this is a very slight adjustment, we think, to the UPS check for multi-step problem solving, but it might be something that you want to consider. So when it comes to our multi-step problems, again, we're going to focus on those word problem schemas. And so we're going to take all that schema knowledge with us and apply it to multi-step problems. So I'm going to move over to problem A. So we're going to talk about the Leslie and her 3 pizzas. Speaking of pizzas, I must have had pizzas on my brain. So we're going to look at this problem here, problem A, and I'm going to talk you through how we teach students to set up and solve this problem. this one looks really simple, right? This just has like almost just like 3 lines of a word problem, but it is still a multi-step problem. And so we need to help students think through how to solve that. All right, so I see a, a word problem that's a mix of numbers and words. So immediately I'm going to pull out my attack strategy, just going to write it here on the side. And now I'm going to understand this problem by reading it. Leslie had 3 pizzas. Each pizza was cut into 8 pieces. Leslie ate 2 pieces. How many pieces were left? So in this story, I have to focus on, I've got this pizza that was cut into pieces and how many pieces were left. So I still am only going to underline one thing here. I could also underline pizzas if I want to think that I'm focusing first about the pizzas and then on the pieces of pizza, especially after Leslie ate some. So I've got an understanding of the problem. Now I need to make a plan. All right, so this is where we have to start to have some discussions. Well, what's going on in this story? Well, first, we see that Leslie had 3 pizzas and each pizza was cut into 8 pieces. So this is where I might put, well, first we have 3 pizzas cut into 8 pieces. And sometimes we'll say like, okay, I think that's what we have to focus on first. Those are ones that I wrote about there. And then she ate 2 of those pieces. And so that's what I'm going to have to focus on second. So let's see. So first she has 3 pizzas with 8 pieces. So first I'm going to use my equal groups or equal group schema to figure out how many pieces of pizza she had altogether. And then it looks like she has a change in her pizza. So I'm going to have a change story that happens. So I've got my plan. First, I'm going to focus on the equal groups. So those are my ones. And then I'm going to focus on a change. That's going to be with my 2. All right, I've got my plan. Now let's set up and solve this by schemas. So with equal groups, I have groups times the number in each group equals the product. And let's see, I have 3 pizzas and each were, it had 8 pieces. So 3 times 8 equals, I could put a question mark here, or I could just start to solve it, but question mark equals 24 pieces. Now I have a change. So I have a start amount of pizza, and if I ate some, that's a decrease in my pizza to a new end amount. So now I started with 24 pieces and I ate 2. So I have to figure out how many I have now. So 24 minus 2 is 22, and a good label for 22 would be pieces. So I've solved the problem, and now I want to go back and check my work. And often this is going to be a more macro level question about, well, does this make sense? If you started with 24 pieces, 3 times 8 is 24, and you ate 2, so I would expect that my answer now, my product, or not my product, my difference would be less than 24. 22 is less than 24, 24 minus 2 is 22. So I've gone back to check my work for the reasonableness of the answer. So here you can see it's like a little bit more of the understanding of the problem, and the planning is necessary to then focus on, well, first I have equal groups and then change. Now, one of the things we are teaching our students, and we're working right now with students in 4th, 5th, and 6th grade, is we are trying to teach them that they don't always have to do this in 2 separate equations. And I'm just going to show you this today to float this idea out there. But what we're trying to teach our students, and I'll write it here on the back of this page here, is that first you have to figure out, well, how much pizza you have. And then you have the change in your pizza. So we can actually use one equation to represent this word problem schema instead of 2 separate equations. Now this is, I don't think, for all students. I think it's a little bit more complex, but we like it because it's also a little bit more algebraic, and so it's getting students to reason algebraically and think a little bit more about, well, what are you doing first and then second? So here I would end up solving 24 minus 2 equals, same thing, 22 pieces. Either works. And so you know your students and what your students are going to understand and have comfortability with. And so think about, well, do you want to teach multi-step problem solving in this way or in this way? And how we set this up is we actually talk about, well, first you have to do the groups times the number in each group. And then this ends up becoming your start amount, and then you have a change from there. And so we kind of show how these equations relate to each other. So then writing the equation, just like I did before, just like that, which I think is pretty neat. And at the end of this school year, we'll tell you a lot more about how well that's working. We've been doing this for a long time. And so now we're trying to transition to one equation that represents two schemas. All right, so I'm going to pause there because I would like you to look at this story about Mr. Khan and his balloons. It is not the same. Let's see. It's kind of similar, but it's not the exact. It's not the same two schemas that we just used. So I'll give you 2 minutes to talk about this problem, and then we'll debrief, and then we'll head down here to a monster of a problem, which will be problem C. So give problem B a try. All right, so hopefully everyone had a chance to do a little work here. So I interpreted this first as a comparison. So first I needed to figure out, well, he has 3 times as many white balloons as red balloons. So first I was going to focus on that. And then I needed to figure out the total number of balloons that Mr. Khan gave away. So second, I was going to add 8 plus 6 plus then the product that we figured out by the number of balloons that the white balloons that he gave away. These are every single one of these word problems that we have worked on, I have found on a standardized test. So I don't make these up. Sometimes I wish I did because I don't think they're always well written. But I wanted to talk about this problem here because there's lots of words here that can be distracting. So gave away, a lot of students might think, oh, I'm going to have to subtract, right? Total, a lot of students might think, oh, I just have to add. And so I could see a lot of students answering this as 8 plus 3, 11 plus 6 more equals 17 because they see that word total. Or they might say, oh, I have to give away something. So I feel like this word problem is one of those where you can see that we can't just rely on keywords to be our problem solving strategy, because none of these words in here would actually lead us to the correct solution. And in fact, it's not that important that he gave away these balloons. Here, it's more important that we're trying to figure out the total number of balloons that Mr. Khan had, whether he gave them away or not. So this is where we really have to focus on a deeper understanding of these word problems. We can't just say, oh, when you see that word, that means you're going to do that. Keywords don't work in multi-step problem solving, and I think we've figured it out only about 9% of the time. So that's where students are going to have much stronger strategies to solve these problems as such. Now, there are other ways that you could have done this, or you could have done something first and then another thing second. If anybody had a different way that they solved this problem, if they want to unmute their microphone and share, I'd love to hear about it.
I did the same thing, but I did it like
Did you different?
parentheses 3 times 6,
Oh,
parentheses
okay.
8
Yeah.
plus 6. I put it in the other form.
Okay, yeah, I mean, that's going to work. And that's a good discussion to have with students about, 3 times 6 is the same as 6 times 3, keep bringing in your commutative property and that type of thing. So it sounds like we are thinking about this similarly, but I like that you bring this up because there are, different ways that students may order their numbers. There might be things that students do first and I did second. And all of that is okay. We want to have flexibility in how students approach and solve these word problems. So I'm glad you brought that up. Okay, so I want to spend a little bit of time solving this problem here, problem C. Some of you may have seen this problem. This is a release item from a standardized test. So sometimes those make their way into lots of different classroom practice. But I'm going to give you about a minute or so to just start and digest this problem. There are several different ways that we can approach it, but with any of your ways, you are going to be using multiple schemas. So I'd like you to read the problem, figure out how you would teach this to your students, and then I'll show you a little bit about how I would approach this, and then I'd like you to share some other ways that you could approach this problem as well. All right, is everyone having fun with this egg problem so far? Oh, I hope so. All right, I think I will say this is a little bit more of an involved problem than we usually see. But this is, usually on every high stakes test, there are one or two of these more like performance tasks, and that's what this is. Now I'll talk about how I would approach this. Again, there are different entry points into this. But first I thought, okay, so I read the problem. I wanted to focus on each side of the cartons, and then I have to figure the eggs. So there's like 2 questions I have to answer here. I'm not just done at some point. And then I made my plan to first focus on the total. So I wanted to figure out how many large cartons there were. So I added the small cartons plus medium cartons plus, I don't know, large cartons to equal basically like 1. And I figured out that 1/6 of the cartons were large. So then I plugged that into my problem there. And then I started to use the proportions graphic organizer. Well, I didn't use the graphic organizer. I used the equations here to figure out, well, if 1 is to 6 as x is to 264, I wanted to figure out, well, what is the number of small cartons? And because I have 1/6 for both small and large, I could figure out I have 44 small cartons and 44 large cartons. And then I use that same schema to figure out the number of medium cartons. And so I was right there. So now I know, well, how many of each size of carton? I can answer this first part. But then, and I know in our breakout group, we were talking about color coding. I was going to change here, then I would need a little bit more space. But now I would use the equal groups graphic organizers and the schema to then focus on the number of small, medium, and large to figure out the numbers of eggs. So here I know that if I have groups times the number in each group equals the product. So just focusing on the small eggs, I have 44 cartons with 8 in each. So 44 times 8, if I remember correctly, I think it's 352. I'll kind of use my brain to remember that. So I have 352 small eggs, and then I would do the same thing for the medium eggs and the same thing for the large eggs. So for this problem, I might end up having, multiple schemas that I've used, and then I repeat some schemas. And this is quite a large problem. But if I have this schema knowledge, I can use it to break this problem down into manageable steps. So if anyone has finished, or if anyone is close to being finished, if you solved this in a little bit of a different way, please go ahead and unmute your microphone and tell us how you approach this problem.
Okay, this is Terry.
Hey, Terry.
Hi. What I did first is I actually did the proportions first.
Okay, yeah.
And then I went back and I just said I need to have 264 total cartons. So
and then kind of figured out that total. That's great. Yeah. Yep. That works.
Hi, this is
just
Christine.
Well. Hey, Christine.
I did mine a little differently too. And I missed Wednesday, unfortunately. So I hope this
that's okay. Yeah.
So I did the comparison first to figure out the number of cartons. So
okay.
For me, my set was the 1/6.
Oh, okay.
Times
and then you have
the total
the size.
Number.
Okay. Yeah.
So that's how I figured out. And then once I had done that for the first 2, the small and the medium size, then I did, which I probably could have done it in a more effective way, but I did a total schema. Mm-hmm. So my P1 was the 44 and my P2 was the 176.
And
So
then
I
you,
got a total and then I did a comparison schema. So,
okay.
sorry, the change schema.
Yeah, the
So
264 minus
minus
the,
the
yeah,
220. So I used,
okay.
that information, that 220. So once I had them, then I did the comparison to get the total number of eggs in each carton.
Yeah, so I think that both what you, Terry and Christine are talking about here is, but you're still focused on this schema knowledge, right? You're still organizing this into, well, I'm seeing that then there's a change in the number of cartons, or I'm seeing that I'm comparing the cartons and I'm figuring out the difference, or I'm seeing that I have a 3-part total and that type of thing. So and I think this is actually a great problem because there's no singular starting point. With problem A here, we pretty much have to focus on how many pieces of pizza Leslie had before we can focus on what she ate, right? This is a little bit more of a traditional multi-step problem. Here, multiple entry points, multiple ways to solve it. I'd like to get it down to where it isn't 6 different steps, but it might take a student 5 or 6 or 7 steps to solve this problem. But in both of your ways that you're talking about it, you are really focused on the structure and like the deep understanding of this problem, and that's what we want to get students to understand. So that's great. Did anyone else have a different way of solving this problem? All right. So I want to leave just a few minutes for wrap up and questions. So on your second page of your handouts, there are some more multi-step problems. There's nothing really new in these. I just wanted to show you that pretty much time and time again, students are asked to combine their schema knowledge. And so really thinking about the interpretation of the problems, and then where are you going to start, and then how are you going to finish the problem. So if you want to solve those and if you want to talk to me about those, feel free to reach out after this session. So as we wrap up, I will leave up our Jamboard for a while. So we've got all 6 of those schemas there and our attack strategies. So feel free to add more to that collection and to go back and be reflective of, well, what is a total problem and what is an equal groups problem and that type of thing. A few other resources that I wanted to share is that I have made a video about all of this word problem stuff. I know you'll have video from this, our week and our 3 sessions, but if you visit the National Center for Intensive Intervention, that's run by the American Institutes for Research, there's a math course that we've created. And if you don't want to type in this really long web address here, you can just Google NCII math course and it comes up. But in one of the modules, it's actually module 5, part 2, there's a whole hour about word problem solving. And so you can see I in real time solve these word problems. So if you want to see some examples of that beyond what we've seen here in our meetings this week, you're welcome to access that. And also, some colleagues and I wrote a book related specifically to middle school, but it has a lot of carryover into high school as well. And I don't make money from this book, so I feel free telling you about it. But in this book, we talk all about these attack strategies. So here you can see this is one of the page where we talk about different attack strategies. I give examples of all the schemas and that type of thing. And it has a lot of really other great stuff about teaching math in middle school in an MTSS framework, so about assessment and other instructional strategies. And a lot of the stuff we did today, you will see in that book. And so I'll finish there by again sharing, whoops, I got a step ahead of me. I'll finish there by sharing my contact information. And if you want to talk more about this, please feel free to email me, or if you want different resources, I'm always happy to share. Find me on Twitter and also download all of the information that we've talked about. It's all yours now, and share it with your general education teachers or others. And I've actually had teachers share some of these things, like some of these slides with students where we have the pictures and the graphic organizers and that type of thing. So my information is now your information, so please go forth and use it. So I'll leave a little bit of time here. We've just got about 4 or 5 minutes. If there are any questions, if you want to type them in the chat box, or if you want to unmute your microphone and ask them, I'm happy to have a conversation right now. That would be great.
Dr. Powell, I just want to let you
Yeah.
know,
Hey,
this
Joanne.
is all great information. I'm a brand
Oh,
new
good.
math teacher, and so I didn't know a lot of these. And
Yeah.
we're good.
Well,
Thank you.
welcome to the Cool Math Teachers Club.
Yeah.
We're glad you're
Thank
with
you.
us.
Thank you. Thank you. Well, thank you for everything.
Yeah, thanks. Thanks, Jacqueline. Thanks, Jessica. Yeah. And Samantha, I will email you after this session. I just saw that.
Thank you.
Thank you. You're welcome. Yeah. I think the thing, if nobody has a lot of questions about word problem solving, is that it's a continual effort, right? It's not something that can be relegated to Fridays because, hey, we have extra time on that day. It has to be something that students are doing all the time. So really thinking about teaching through problem solving. So maybe if you're teaching geometry, but introducing that through word problem solving scenarios, and really giving students times to practice and think and discuss. And as you can see with that egg problem, oh my gosh, there's a lot going on there. And that might be a problem that takes us 2 days to solve, right? So really thinking about giving students many opportunities to solve word problems, because whether we like it or not, students show their math competency through problem solving. And so if we aren't doing this regularly in the classroom, it's really going to prohibit students from showing the math competency that we know that many of them have. So. Well, thanks, Sarah and Deidre and Christine and everyone. Yes, and you can access all these resources on the website. I usually leave them up there for about 2 or 3 months. So if you just go to the website and click on presentations, it's all there. I've also on the front page of the website right now have tons of video resources, mostly during school closures. I try to put as many video resources up as possible. So they're all there and welcome for you to take. So thanks, Shelley. That's awesome. We wrote that last summer and have gotten it out, and a lot of people have really enjoyed it. So hopefully you will too. So, and thanks, Jacqueline. Tell anyone to come and talk more word problem solving with us. And just thanks so much for spending the week with me, and I hope your school year gets off to a great and healthy and safe start.